Hello there, this is Ant Johnson, and this is another episode of SQL Interview Prep. So the interviewer asks you, what is normalization? Normalization is the process of breaking down a large data set, typically one table, breaking it down into smaller tables, and placing relationships between the two, meaning like using primary and foreign key relationships. Normalization comes about more so when you're dealing with OLATP opposed to OLAP. So OLATP, online transactional processing. And it comes from the Snowflake schema, which is, as I mentioned before, breaking down large data sets into smaller tables and linking them with relationships. So a little bit more about normalization. Normalization is the reduction of redundant data. So that's typically the second part of the answer. So the first part would be is the breaking down of large data sets and making them into smaller tables and linking them with relationships. Also, it's the reduction of redundant data. You have a few normal forms. That's what NF stands for, normal form. 1NF, 2NF, 3NF, 4NF, and BCNF, which stands for Boyd Cod normal form. But 1NF, 2, 3NF are the most commonly asked about normal forms. We accomplish this, as I mentioned before. I just want to hammer this home. It is the breaking down of a large table into many tables and linking them with relationships, i.e. a primary key and foreign key relationship. So first normal form, it is the elimination of repeating groups. Each group or each column should have atomic values in them. So if we look at the first diagram, we see that in the courses column, we have math separated by a comma and physics. And then we have at the bottom physics, comma, biology. That is an infraction on the first normal form. So if you look at the second diagram, we essentially gave every course name its own ID, which is a primary key. So we broke that table down into another table, which probably would be called courses, and we gave them their own unique identifier. So if you look at the third diagram, this is essentially what we are looking for. Although Alice repeats twice and Carol repeats twice, they don't have multiple courses within one row. So we rather the data repeats a couple times, but they have a unique combination amongst each row. So the second normal form, elimination of repeating data. We achieve this by splitting the data into two tables. So if you see here, data before the second normal form, you see we have our student number column, our course number column, and our course fee column. So course fee is dependent upon course number. As you can see, the two highlighted rows that I have here on the first diagram. We have C1, which is 1,000, and C1, which is 1,000. So the course one, C1, is $1,000, which we don't need it to be repeated twice. We would rather have just C1 on there twice opposed to actually having a whole nother column, which is course fee, displaying the actual price. So what we do here is we take the student number and the course number and we create a unique combination amongst the two. So let's compare the diagram. You see number 1 and number 4, they both have C1. If you see, look over here, 1 and 4 both have C1, but they're unique though, because 1 has C1 and then 4 has C1. Hopefully I didn't confuse you there. Go to the third diagram, and as you can see, we have a course number table. We have a courses table where each course number is its own unique identifier with the respective course fee prices. So opposed to having course fee on the table, we would just have the course ID number. And that is second normal form because we are eliminating repeating data. We don't need this, and it's repeating a multitude of times. Imagine if this was a million rows, you just have this column over here. Not only does it suck up resources, it's just not congruent to keeping data and its integrity intact. So down to the last one, the third normal form, which is the elimination of non-key dependent values. So We have 3 tables here. This is in the Northwinds database, which you can download from Microsoft. We have the orders table, the orders details table, and the customers table. So if you see here, these tables can all be linked. If I run a join and link them through the order ID and then link the customer ID to the orders table, I will bring up the congruent data amongst the inner joins, opposed to just having all 3 of these tables combined and placed on one data set. That is what is called denormalization, and that is going towards the star schema, but we're in the snowflake schema. So again, normalization is the process of eliminating redundant data. It is achieved by breaking down large data sets into smaller tables and linking them through key relationships. You have your 1NF, your 2NF, your 3NF, your 4NF, and your BCNF. First, your 1NF repeats repeating groups. 2NF is the elimination of redundant data. And 3NF, which is here on the screen, is the elimination of non-key dependent values. So if that value is not tied to a primary key in another table, it shouldn't be there. That will be an friction on the third normal form. So I hope this was helpful. This was another episode of SQL Interview Prep. I hope you guys have a blessed day, and bye-bye.